Today we're going to be talking about acid-base, and specifically I'm going to go through a very easy, direct way to interpret pH and decide whether it's metabolic, whether it's respiratory, whether it's acidosis, whether it's alkalosis, and when you're done today, you'll be able to crank this out in less than 20 seconds, I promise. So why don't we get started? The only thing that you're going to have to memorize today is right here on this slide. So you need to know that when you set up the pH equation, it's bicarb over carbon dioxide. You also need to know the normal values. So a normal pH is 7.40. A normal bicarb, which is our numerator, is 24. And a normal carbon dioxide, which is our denominator, is 40. Additionally, anytime we're dealing with changes in bicarbonate, we refer to that as metabolic. Whereas anytime we deal with changes in carbon dioxide, we refer to that as respiratory. The other thing that you need to know is that when pH goes up, i.e. it's greater than 7.40, we call that an alkalosis. Likewise, when the pH goes down and it's less than 7.40, we call that an acidosis. Okay, so again, everything that you need to memorize is right here on this slide. It's simple, stare at it for a couple minutes and you'll be ready to go. Now here are the steps for how you do this. I'm going to go through them now, but we're going to do two examples that will make them very, very simple. First, what you do is you assign arrows for increases or decreases in our three main values, which are pH, bicarbonate, and carbon dioxide. You then name the primary deficit, and then after that, you name a compensation if one exists at all. So what we're going to do now is we're going to go into two examples which will illustrate this and make it very, very simple to understand. So here's example one. You're given a patient and these are his values. He has a pH of 7.31, he has a bicarbonate of 18, and he has a carbon dioxide of 28. So the first step we said was to assign arrows. So given that we know the normal values for each of these three variables, we need to then decide how does this patient's values deviate from normal. So when we do that, here's what we see. We know that his pH is down because normal pH should be 7.40, but his is 7.31, therefore pH is down. We know that his bicarbonate is also down because what's the normal bicarbonate? Well, that's our numerator and it's 24. So this patient has a decreased bicarbonate. And then for carbon dioxide, it's also decreased because we said that carbon dioxide, our denominator, should normally be 40. So all three of his values are decreased. So the next step we said is to name the primary deficit and the compensation. So what we do is we set up our equation with his values. We say that 7.31 is equal to 18 over 28. And that's just saying that pH is equal to bicarbonate divided by carbon dioxide. And we just plugged in the values. We then have to name his deviations. So what we're going to do is we're going to look at the numerator and denominator and decide how those changes will affect the pH. So let's start with the pH. The pH is 7.31. I told you that when pH drops below 7.4, that's called an acidosis. So we name this an acidosis. Now we need to look at the numerator and denominator. The numerator is 18. Our bicarb is down. What happens to the number that an equation is equal to when you decrease the numerator? Well, it goes down. A decreased numerator means a decreased number that the equation is equal to. So we named the bicarb being 18 as a metabolic acidosis. Now let me explain how we arrived at that. It's metabolic because we're dealing with bicarb. I said that bicarb is always metabolic and CO2 is always respiratory. But why is it an acidosis? When we move from the normal value of 24 and we decrease that to 18, we're decreasing the numerator. If we decrease the numerator, we expect the pH to drop. And when the pH drops, it's called an acidosis. So again, bicarb dropping is metabolic because it's bicarb, and acidosis because the numerator decreases, which we expect to decrease the pH. Now let's look at the denominator. Carbon dioxide is 28. 28 is decreased from the normal value of 40. So if the denominator decreases, what do we expect to happen to pH? Well, anytime you have a mathematical equation and you decrease the denominator, the number that it's set equal to should increase. And if the pH were to theoretically increase, that would be an alkalosis because it would be increasing above 7.40. It's respiratory because it's carbon dioxide that we're dealing with. So now we've named all three of these deviations from the normal values. We then have to decide what is our primary deficit? Now, the way that you do this is you look at the actual, you look at the pH. We've said that the pH is an acidosis. We then have to just match that up with the numerator and the denominator and see which one is the acidosis. In this case, the only acidosis is our metabolic acidosis. So that matches the pH acidosis. And because they match, we know that the primary deficit is the metabolic acidosis. But this means that the compensation is the other change in variables. So because our primary deficit is a metabolic acidosis, our compensation is a respiratory alkalosis. And that makes sense. I mean, think about it, guys. The pH is dropping. It's an acidosis, and it's caused by a metabolic acidosis. Your body is going to try to compensate for that metabolic acidosis, and it's going to try to raise your pH. And it's going to do that by using carbon dioxide. It's going to use the system opposite the system that is causing the pathology. So in this case, the pathology is caused by metabolic acidosis. That's bicarb. Your body's going to tap into its ability to control carbon dioxide and try to drive that pH back up. That's a respiratory alkalosis. So on a test, on USMLE or to an attending, when they ask you what is the deficit, how do we name this? This is called a metabolic acidosis with compensatory respiratory alkalosis. Okay? We're going to do one more example to drive this home. Here's example 2. The pH is 7.33, the bicarb is 30, and the carbon dioxide is 54. So what's step 1? We assign our arrows and decide how these values are moving from the normal. And here's what we got. pH has dropped. It's gone below 7.40. Bicarb, we said, should normally be 24. That means it went up. It went up to 30. And our denominator, carbon dioxide, should usually be 40, but in this case it's up. It's driven up to 54. So we're going to set up our equation, and now we're going to name the primary and compensation. So here's the equation. 7.33 is equal to 30 over 54. Again, that's just pH is equal to bicarb over carbon dioxide. Now, pH went down. We know it's an acidosis. Bicarb went up. When we're dealing with bicarb, we call that metabolic. Bicarb going up, aka the numerator increasing, should do what to the pH? Well, it should drive it up. So in theory, that's a metabolic alkalosis. Carbon dioxide going up means that the denominator increases. Anytime you increase the denominator, the number that the equation is set equal to is expected to go down. So in theory, that's a respiratory acidosis. Now, I've kind of revealed it by highlighting it in blue here, but we need to decide what's the primary deficit and what's the compensation. We said that you always match the pH to the pathology, whether it's metabolic or respiratory. So in this case, the pH is an acidosis. Which one of our two changes between bicarb and carbon dioxide is an acidosis? Well, that's our respiratory acidosis. So we know that the primary deficit here that's causing the pathology, that's causing the deviation in pH and the change in normal values is a respiratory acidosis, which means the compensation has to be metabolic alkalosis. And then we're going to ask ourselves, does that make sense? Well, respiratory acidosis means that carbon dioxide is causing a decrease in pH, which means the body is going to use the opposite system, which is the bicarb or the metabolic side, to drive the pH back up because it's decreased. And that makes sense because a metabolic alkalosis is just that. Metabolic alkalosis would be an attempt to fix a respiratory acidosis. So when we name this one, we call it a respiratory acidosis with compensatory metabolic alkalosis. Okay, guys, that's all I have for you today. Try practicing a couple of these and drawing out values and seeing if you can do it on your own. It's very high yield for step 1 to be able to crank this out in less than 25 seconds. It'll save you a ton of time on a question, and good luck out there.